Hello student, here's a question which says a whistle of frequency 500 Hz tied to the end of a string of length 1.2 meter revolves at 400 revolutions per minute. A listener is standing some distance away in the plane of the rotation of the whistle hears frequency in the range of. Okay, so you have to draw the diagram first. Suppose this one is a circle and the circle is horizontal. Okay, so the particle is rotating in this circle. Okay, and suppose a man is standing at some distance. It may be this side or it may be this side, so I am taking the person in this side. Okay, now you have said that the whistle of frequency of the whistle is 500 hertz. 500 hertz, and the radius of this string, yeah, length of this string is 1.2 meter. So the radius of the circle is also 1.2 meter. And the frequency of revolution is 400 revolutions per minute, or you can say it as 400 revolution upon 60 per second. Okay, we have changed it in second from revolution per minute to revolution per second. So this is the frequency. Now the listener is standing at some distance, hears the frequency. Okay, so what is the range? So if we will concentrate on the circle, then we observe that if the whistle is at this point and we are taking the motion in anti-clockwise direction. Okay, so if the whistle is in this point, then the whistle is going in this direction. Means the sound produced by the whistle is going in this direction. And if the whistle is diametrically opposite at this point, then the sound produced by the whistle is going in this direction. So you can say that for this case, the sound velocity is in the direction of the person, and for in this case, the sound velocity is opposite to the direction of the person. So here the person will hear the maximum frequency. So here the person will experience the maximum frequency, and when the whistle is at this point, the person will experience the minimum frequency. And we will not take any other points rather than these 2 points, because at every point the direction of the sound will be altered here. Okay, and here this direction, here in this direction. So the most suitable condition for the maximum is that the sound should come towards the man, and for the most suitable condition for the minimum is that the sound should go away from the listener. Okay, so we are taking the maximum situation. Okay, so for maximum situation we will observe here that the source is moving in this direction, the person is standing here, so velocity of the observer is 0, the source is moving in this direction, and sound is going from the source to the man. Okay, and we know from Doppler's effect that f dash equals to f into v upon v. In numerator we put the observer, and in denominator we put the source with plus and negative signs respectively. As the observer is not moving, so we will put plus minus 0, so you don't have to write it. Okay, now in the denominator we put the value of the source, and since the velocity of sound and velocity of the source is in same direction, so it will be v plus v minus vs, because both are in same direction. So this will give you the value of maximum frequency. Okay, so this will give you the value of maximum frequency, and the f is the value of the sound produced, frequency of the sound produced, which is Frequency of the vessel 500 Hz. V is the speed of sound and Vs is the speed of source. To calculate Vs, we will use the formula omega into R, and omega is written as 2 pi f into R, and the frequency is 400 upon 60 revolution per second. So 2 pi into 400 upon 60 revolution per second into radius or length is 1.2 meter. So it is 1.2. Okay, now we will solve this. Sorry, here will be 0 only, 1.2 hai. So this is 10. Okay, so 6 into 2 12, 2 into 2 4, 4 into 4 16. So 1.6 pi. 4 into 2 8, 8 into 2 16 divided by 10, 1.6 pi, and 1.6 pi will be 1.6 into 3.14, which is 5.024. Okay, so this is the speed in meter per second. Now put these values here. So f dash maximum equals to f is 500 hertz into, we have to take the speed of sound as 340. So 340 divided by 340 minus 5.024, it will be 340 minus 5.024. So 500 into 340 divided by 334.976 divided by, now the final answer is 334.976, 507.5 hertz. Okay, 507.5 hertz. I think we have made some calculation error, because here is I think the calculation error is here. So 2 into pi, okay, 400 upon 60, yes, there is a calculation error for 600. So here not 600, it is 6. Okay, so the both zeros are cancelled out and it is 1.6 pi, it will be 50.24. I'm really sorry for this, 50.24. So now here we will solve it, and it will be 586. So 340 minus 50, so 500 into 340 divided by 290, so it is 586. Okay, so we have two options having 586. So this is 586. Okay, now for the minimum frequency we can write as f dash minimum equals to f. Now the diagram will be for this situation. Here the source is moving in this direction, so this is the direction for the velocity of source, this is the observer, and sound travels from source to observer. Now the formula will be V upon V plus Vs, because both are in opposite direction. These both are in opposite direction. So it is 500 and V is 340, and 340 plus 50.24. Okay. So it will be 500 into 340 divided by 290 approx, plus 390. 500 into 340 divided by 390. So it is nearly equal to 436 hertz. So this is the minimum frequency. So I think the fourth option is the correct option. The range is from 436 minimum frequency to 586 hertz maximum frequency. I hope that you understood this question. Thank you.